This is part 3 of 3 for this multiple choice BC test. So here we go, 21. Which of the following is the interval of convergence for this series? To find the interval of convergence, you've got to do the ratio test. But I do, since this is x plus 4 here, I know that the center of the interval has to be negative 4. Right? Because this is a series. If you start writing out the terms, they're all going to have like x plus 4, x plus 4. This is a Taylor series centered at x equals negative 4. That's just a given. I know that because I know about series stuff. So let's just look at these real quick and see what's centered at negative 4. I guess it could be this. It could converge everywhere, but I don't think. I suppose I should just do the ratio test, but I don't think that that's going to be the case because it's like a 1 over n series, and then this is geometric, and geometric series converge usually like on the the r has to be less than 1. So I'm thinking it looks like it's going to have like a radius of 5 would be the most likely thing. So if you're confident about that. You could look at these and say, okay, this is not centered. This is definitely not the right answer because that's centered at 0, and this is centered at negative 4. So it cannot be that. This is, so we're really narrowing this down, I think. This is centered at 5, and we need a series that's centered at negative 4. This is centered at negative 4, so this is a contender, and it has a radius of 5, so I'm liking this answer a lot. So here's what I'm going to do. If this is the right answer, then if I plug negative 9 in, I get convergence, and if I plug 1 in, I don't get convergence. So let's see what happens here. If I plug negative 9 in, I get... So effectively what I'm doing here is just checking the endpoints. Negative 9 there would give me negative 5 to the n over n times 5 to the n plus 1. Right? Okay, so what does that do? 5 to the n plus 1 is the same as 5 times 5 to the n. So that's the same as negative 5 over 5 to the n times 1 extra 5 on the bottom and the n there. Hope you're okay with that. I just split this up into 5 to the n and 5 to the 1. So the 5 to the n I put in here. So this whole thing that's like negative 1 to the n. So this is an alternating series that's basically the harmonic series with a 5 multiplier on the bottom. And of course that doesn't change convergence or not. So this is alternating harmonic that converges, and then if I plug in x equals positive 1, I get 5 to the n over 5 to the n plus 1. That's an extra 5 on the bottom. That's the series 1 over 5n, which is like the harmonic series, and that diverges. So sure enough, it's that. Real quick, just for practice, you don't have to do it to figure out what the right answer is for this one, but the ratio test would look like this. The limit as n approaches infinity, the n plus 1 term would be x plus 4 to the n plus 1 over n plus 1 times 5 to the n plus 2. Then divide by this, same as multiplying by the reciprocal. And that's equal to the limit as n approaches infinity. The x part, I've got x plus 4 here. That would actually go on the outside here because the x's don't have anything to do with n going to infinity. So I can factor out the extra x plus 4. And then on the inside, I've got n over n plus 1. And then 1 extra 5 on the bottom. The limit as n approaches infinity of this is 1. So I get 1/5 times x to the 4. And what we're doing here with the ratio test, I would take that and say, okay, that's got to be in between -1 and 1, multiply by 5. So there's, you can see why that answer is there. But I have a plus 4 in here, so subtract 4, minus 9, and 1. So at this point, if you did the ratio test, you would be done, because there's no, you're supposed to check the endpoints, but this is the only contender at that point, right? So don't do more work than you need to. And if you realize that the series is centered at -4, that basically just limits it to this. Limits it, get it? Except for the fact that it could converge everywhere. But as soon as you check these endpoints and you see that one diverges, then obviously it can't be converging everywhere if it diverges at 1. So I think that, I don't know if this is really by design from the College Board, but I think that the way this problem plays out, you either do the ratio test and then realize you don't have to check the endpoints, or you check the endpoints and then realize that you don't have to, or you circumvent doing the ratio test. So either way, it shouldn't be like the whole like ratio test and checking the endpoints. All right, so there's 6.5 minutes on the first problem. What's the slope of the tangent line to the polar curve where theta equals pi over 2? I know how to do that. I just need to find the slope of polar curve is dy d theta over dx d theta. Right? So I need to parameterize this. So y is equal to r sine theta, and x is equal to r cosine theta. Why did I write the y first? Because I'm interested in the slope that's going to go on top, so I'm just going to keep them in that order so I can kind of build toward that expression. So dy d theta is equal to the derivative of this using the product rule, the derivative of the first times the second plus the first times the derivative of the second over dx d theta is equal to the derivative of the first times the second plus, I'm going to write a minus sign because I'm looking ahead a little bit, plus the first times the derivative of the second. The derivative of cosine is negative sine. Okay, so there's my slope expression. I just have to plug that into it. So the sine of pi over 2 is 1, and the cosine of pi over 2 is 0, right? So that's going to go away, and that's going to go away when I plug in the pi over 2. So 3 times 1 over minus 3 theta times 1. So that looks like, if I simplify that, it's minus 2 over pi, which is answer choice B. All right. The definite integral, this, is approximated by a left Riemann sum, a right Riemann sum, and a trapezoid sum, each with 4 subintervals of equal width. And we want to put them in order from smallest to biggest. So what does this square root function look like? It looks like this. And the important thing for us here in ordering these things, we don't have to find all of these. We just have to notice two things: that this function is increasing and it's concave down. So I'm just going to draw in a couple of the rectangles and stuff. So the left, because it's increasing, the left Riemann sum is definitely going to be, where you take the left endpoint, that's going to be the smallest one. And the trapezoid sum, that's like connecting the dots here, because it's concave down, it's bulging up a little bit like this above those lines. So that means that the trapezoids are going to be a little bit smaller than the real thing. The trapezoids are a little bit smaller than the actual area. So this is the right answer. Didn't have to go past the first two. And then just to check, then I'd have the actual area, and then if you take the right endpoints, because it's increasing, the right endpoint is the highest point in each subinterval, so that's going to be the biggest. So that's that. Didn't have to compute them. Graph of the piecewise linear function f is shown above. What's the value of this? Fundamental theorem of calculus. This is a graph of f, so we're not finding the area. We're not doing this. That's not what this, so we're not finding this area. That's not what this is. If we were being asked to find what's the area from 0 to 12 under the f function, then I would do this, these triangles. But that's not what I'm being asked. So that is definitely tempting but wrong. Fundamental theorem says that, right? So it's just f of 12 minus f of 0. F of 12, this is a graph of f, is negative 4, and f of 0 is 4. That's negative 8. Function f has continuous derivative. Okay, if it has a continuous derivative, that means that f is differentiable. I don't know if that's going to be important. We'll see. F of 0 is equal to 1. F of 2 is 5. This. So what's this? Look, a product. So if I'm going to find the integral or antiderivative of a product, that is going to be integration by parts. So if I make u equal to x and dv equal to f prime of x dx, that looks like it's going to be successful because that gets me back to just f of x. Okay, so integration by parts is that the integral of u dv is equal to uv minus integral v du. So this is equal to uv, oops, I want to write uv, I want to write what they are, x times f of x minus the integral v du, and going from excuse me, 0 to 2. So this part we already evaluated, right? But I still have to plug in the 2 and the 0. And I think we have everything that we need now, should do. So plugging 2 into this gives me 2 times f of 2 minus plugging 0 into this gives me 0 times f of 0. And of course that's going to go away. Minus, they just told us what this integral is, right? The integral from 0 to 2 of f of x dx is 7. Okay, so 2 times f of 2 is 5, so that's 10, minus 7 is 3. All right. Which of the following series are conditionally convergent? This would converge with the factorial on the bottom. That's going to converge whether it's alternating or not, right? Because 1 over n factorial, that converges. That's actually the e to the x function. That's what that would converge to. It would converge to e. How about this? This is a series with a p of 1/2. Those terms do get smaller, but the p is not greater than 1, so this is conditional. And then this is also conditional. This by limit comparison, same as the harmonic series. So it's only converging because it's alternating. So 2 and 3. Let R be the region in the first quadrant bounded by the graph of y equals x minus 1. That's the square root function shifted over 1. So like this. And the vertical line x equals 10. When you plug x equals 10 into this, you get y is equal to 3. I don't know if we need to know that or not. That's x equals 10. So which of the following integrals is the volume of the solid generated by revolving R around the y-axis? So if I'm revolving that this way, this is a dy problem if we're revolving around the y-axis. And this area is defined by this outside radius, which is 10. And the inside radius, which is, if this is the function y equals the square root of x minus 1, then that's the same as y squared is equal to x minus 1. So x equals y squared plus 1. Right, that's looking good there. So the integral would be from y values. Since this is a dy problem, I'm going from here up to here, so from 0 to 3. Outside radius squared minus inside radius, which is that squared. And that's the same as that. The 27 is D. All right, parametric equations, the second derivative. Remember the trick here is the second derivative is, it's the derivative of dy dx, but then you have to divide by an extra dx dt. It's like this funny little, funky little bit of calculus esoterica, but when this comes up, you just have to know to do that. So without doing anything else, I think it's going to be, well, let's go ahead and do it. So the first thing we need to know is that it's probably going to be it's not going to be this one because we have to divide by the extra dx dt. So anyway, let me just write down what it is. So the derivative, when you have parametric stuff, then you take the d dx derivative of, you take the t derivative, because this is going to be in terms of t, and then you divide by dx dt. You can go back and look at the notes in, let's see, somewhere, I think it's very early chapter 11, that I go over the demonstration of why this is true. I'm not going to redo that here, but you can check that out if that's kind of, if it's important to you to see that. But this is how you do it. You find dy dx, and dy dx is just equal to dy dt over dx dt. So dy dt is sine of t squared, and dx dt is 5. So you take the derivative of this, right? That's dy dx. Take the derivative of that. So that's going to be 1/5 times the cosine of t squared times the derivative of what's inside, and then you divide by dx dt. So it looks like that is our correct answer. All right, not hard, but you got to know what to do. It's not hard if you know how to do it. I guess that's true about most things, isn't it? 29. Which of the following expressions is equal to this? Okay, this is a little bit tricky if you don't understand what the heck this is. What this is a Riemann sum. This is how wide each rectangle is, like the delta x, and this is the little f of x for each of the things here. So here's what I'm going to do. I'm going to just pick a number that's not very big, like, I don't know, how about 3. Let n equal 3. And I'm going to plug that in and try to get a sense of what is going on here with these. So if I do that, then this expression turns into 1/3 times 1 over 2 plus 1/3 plus 1 over 2 plus 2/3 plus 1 over 2 plus 3/3, which of course is 3. So what's happening here? I've got rectangles that are 1/3 wide, right? And then they're this high. So 1 over 2 plus 1/3. I guess they'd be getting smaller. Sorry, they'd be looking like more like that. So what is happening here? It looks like this is the integral from 0 to 1 of 1 over 2 plus x. Does that do it? No, I don't think that does it. I think let's see which one of these. Maybe this does do it. Let's check that again. These are the two that I like the best so far because the interval is 1 wide, and like 2 to 3, I don't think the 2 is already here in the function, so that's not going to work. So what does this function give us if I plug in 0? It gives me 1/2. If I plug in 1 into that, it gives me 1/3. So are my values going from, yeah, that's it. So they're 1/3 wide, my rectangles, if I choose n equals 3. And then you can see these are the values. This would be like a right Riemann sum of this with 3 rectangles. So that's a little tricky. My advice is just to like pick a number and try to figure out what's going on and then match that up to one of the answers. Last one. Function f has a Maclaurin series given by this, and the Maclaurin series converges to f of x for all real numbers, so it converges everywhere. If g is the function defined by g of x is equal to e to the f of x, what's the coefficient of x squared in the Maclaurin series for g? Okay, so how do you find the series for g? This e to the, I can't put this whole f of x, I can't put that up there in that exponent. So to do this, I'm going to have to actually find the derivatives here. I don't have to go that far because I only want the coefficient of the x squared term. For g prime, that's going to be derivative of e to the whatever is e to the whatever times the derivative of what's inside. G double prime of x is equal to the derivative of this product rule, derivative of the first, right, that's the derivative of the first, times the second, plus the first, times the derivative of the second. Okay, so the series for the g function, the series for any function, is equal to, this would be like the second degree polynomial. I'm only going to write that many terms because that's all I need to get that coefficient. So for the g function, it's g of x plus g prime of x times x plus g double prime of x over 2 factorial times x squared. So what's the coefficient of x squared? It's the second derivative of the function divided by 2 factorial. So I need to figure out what the second derivative is here. So let's see if we can do that. So what is f, and we need to find that at, sorry, these should be zeros here, g prime of 0. And what I need is to plug in 0 into all these now. I'm just scribbling on that so I don't have to rewrite this stuff. Okay, and then f of 0, f prime of 0, and f double prime of 0 I can get from this. So just like this series is g of 0, yada, yada, yada. So this number right here, that's f of 0. This number right here is f prime of 0. And this number right here, this 1, is f double prime over 2. Right? So if 1 is equal to, because that's the coefficient of that, is equal to f double prime of 0 over 2 factorial, which is 2, then f double prime is equal to 2. That's an easy mistake to make. And I betcha they have the answer here if you had made that equal to 1. Okay, so I think we have enough information now to do this and then divide that by 2 factorial. So what's e to the f of 0 is e squared times f prime of 0 squared is 9 plus e to the f of 0 is e squared times f double prime of 0 is 2 divided by 2 factorial. There it is.